Hi, I am Atharv, a PhD student at Princeton University, and I am here presenting a demo on our work titled AI Agents in Cryptoland Practical Attacks and No Silver Bullet. In our work, we mainly analyze the security issues with ELIZA OS, so I'll give a brief overview of that first. ELIZA OS is a lightweight operating system for building customized AI agents. They can connect to your crypto wallet as well as autonomously interact with social media platforms such as Discord, Twitter, etc. So let's see a simple use case of ELIZA OS first, like creating a bot that can handle crypto wallet transactions. So we interact with the bot using Discord. Currently, we are using a very simple bot with no safeguards as such. Note that anyone can initiate a transfer for this bot, which is a vulnerability by itself. So as you can see, I'm trying to send a transaction to this address, and currently it has 0.09 Sepolia ETH. So I'll execute this transaction. And as you can see, ELIZA is replying right now, and it is sending money over. And there should be a confirmation anytime soon. Yes, so here's the confirmation and the transaction hash, and as you can see, the balance will update just about now. Yes, so here's the new transaction, and as you can see, the balance has increased as well, and the transaction will be approved in a minute. Yes, so the approved transaction is here as well. Our experiments reveal that ELIZA OS is vulnerable even with prompt-based defenses. If a malicious user sends harmful messages beforehand, the same command that we showed previously could lead to a very different outcome. Let's break it down. As you can see, a malicious user over here has sent a message which performs the attack, and the next transaction verifies that the attack has gone through. As you can see, the command over here asks ELIZA to transfer crypto to the address OX406, while ELIZA transfers crypto to the address OXB84, which is what the attacker intended to do. Now, if a whitelisted user tries to interact with the same bot on, say, X, like here, where Krasno ELIZA is the deployed ELIZA bot, let's see what happens. First, as you can see, that the address to which the user wants to transfer money, OXC55, has 0.014 Sepolia ETH, while the address of the attacker has 0.011 Sepolia ETH. Let's see how the transaction goes through. And I've posted the transaction over here, and the output should be here anytime soon. Okay, we do have the response, and let's see what happens. Okay, as you can see, it is sending crypto to the address that the attacker originally intended, B84. And over here, yep, it has sent a transaction to the OXB84 address. And let's see, has the balance increased? Yes, as you can see, it has increased to 0.012, while the account of the original user still has 0.014 Sepolia ETH. Okay, so now let's see how the attack works. On the left side here is the malicious user Melissa interacting with ELIZA OS over Discord, while on the right is Bob, who is the benign approved user interacting with ELIZA OS over X. First, Melissa sends the malicious message on Discord. As you can see, it seems to be composed of multiple messages instructing ELIZA OS to do some task. However, interestingly, ELIZA OS only replies to the last message from the input, the query about flowers. So what's going on over here? Essentially, ELIZA OS stores all the message content into its external memory, and due to the format of the messages, starts believing that they were actually past messages that it has already replied to affirmatively. However, this external memory is shared across sessions and applications. Thus, when Bob interacts with ELIZA OS on X and asks it to transfer to his own address, ELIZA retrieves the past conversations with the instructions to always send to some other address in its memory. And since the attacker has also injected a message where ELIZA approves of this request, ELIZA OS thinks that it has already done this in the past and goes through with it. Thus, it finally makes a transfer to the attacker. This attack shows that the prompt-based defenses are essentially not enough in the agentic setting, and that we need to build stronger and more responsible agents to handle real money.